Hello friends, this is Yash. Welcome to YT Geology Zone. Today I will be explaining you how to find average rainfall using Thiessen Polygon method. So there will be two videos. This is the part 1 and there will be part 2. So this video is a little bit bigger, that's why I have cut it into two parts. This is part 1 and the next will be the part 2. Okay. So I will suggest you to do this example with me. I have explained you with the example. As you know, I always explain with the example only so that you can understand it in a better way. So the question which I am using in this example, its link I have given in the description, so you can download the graph paper using the link in the description and you can print it out and you can do with me. So let's start without any further delay. Hello friends, as I told you, I will be explaining here step by step how to find annual rainfall by Thiessen Polygon method. So in this method, the question will be like this. You will be given a graph paper and on that graph paper the diagram will be drawn. As you can see, the diagram is drawn here, and here the stations will be plotted. So you can see here station A, B, C, D, and there are so many other stations are also there. So here totally 12 stations are present. As you can see, 12 stations are plotted here, and here as where the point of station is given, the rainfall will be given in millimeter of particular station. So I haven't written here, but I have written on a separate table. So the first thing you have to do is to make a table, and you have to make a table in such a way. So you have to write a recording station A, B, C, D, E, F till L. There are total 12 stations, so from A to L. Okay. Then we have to write their rainfall in millimeter, whatever it is given. So in this case, in this question, for example question, the rainfall was given 5.76 millimeter, 4.81 millimeter, and so on. And I will suggest you to do with me this whole question so that you will be understand it very well. I have given the soft copy, the PDF of this graph paper in a link in a description. So you can download it and you can print it out and you can do with me so that you can understand it very well. Because when you only look it or you can only see it, you will watch the video, but you will think, yeah, I understood. But when you will do it, that time you will come to know, okay, so this I have to do. So I will suggest to do with me. And the video will be a little bit longer because I have to explain and I have to scale. I will be doing live in front of everything. So it will take time. Okay friends. So I request you to watch full video. Okay. So the third column is of area of polygon and the fourth column is area weightage rainfall in millimeter. So you have to make a table in this way. You can take a screenshot of it and you can keep it with you. Or you can note it down by pausing the video. Okay. So keeping it aside, so let's start doing the problem. Okay, we have a graph. So what we will require, our requirements, so that we won't go here and there again and again. So the first one is a pencil. If you don't have mechanical pencil, it's okay, but I will suggest you to take mechanical pencil, because in graph work, whenever you plot a line and all, so you have to, because this graph is of a rainfall, so here every millimeter counts. Okay, so take a sharp pencil or a mechanical pencil of 0.5 mm and a protractor, a scale, and the eraser. Okay, so that's it what we required. Yeah, of course a rough notebook and a calculator also, but not now. So let's start it. So these are the steps to find annual rainfall by Thiessen Polygon method. You can take a screenshot or you can note it down. So I will be explaining you step by step. So here, the first step. What is that? Okay, here it is given. It's not a step. So first thing is given. Stations are plotted on a map. Okay. So can we see? Yeah, there are A, B, C, D, E, F, G, H, I, J, and K and L. Okay, there are 12 stations plotted. Okay, he's right. Second thing is given. Now the step 1 is there. Okay, take any station as a starting point. Okay, this is take any station as a starting point. So which station we can take? We can take any station from out of this. So I will be taking I will suggest to take a station which is at the corner. So I will be taking this station number K as a starting point. So we'll just rotate it so that it will be helpful us to draw the lines and all. Okay. Now the second step is connect the adjacent station by straight lines. Okay, we will connect it. So this is our station number K and the adjacent station is station G. So let's connect it. Where is G? G is here, K is here, and it is connected. Okay, so it is connected as we can see. So now our next step number 3, bisect each line perpendicularly. Okay, so to bisect we have to measure the line first, how much it is. So this centimeter, it is nearly 6.2 centimeter, this line is of. So it will bisect at 3.1 centimeter, which will be nearly here. I will mark it. Yeah, I have marked the point. You can note it down, you can see it. And do with me so that you will also understand very well. And this is the protractor. So let's mark it at 90 degree. Where is 90 degree? Yeah, here it is 90 degree, and yeah, I found it out. Okay, so let's bisect it. Okay, I have bisected it. You can see here how this is bisected. So the one thing is that when you will bisect, whatever the bisection you will do here perpendicularly, you have to do within this border only. Okay, you don't have to take any line out of the border. Only the adjacent lines can go out of the border, but no need to bring this perpendicular line out of the border. Okay, so as you can see here, I haven't brought the perpendicular line out of the border, it is in the border. After bisecting it, we have to rub this line, whatever we have drawn, this adjacent line, its work is over. We rub it. Okay, I have rubbed it, and I will make this line again more darker so that it won't be disappeared from the camera. Yeah, okay, I hope you can see it. Yeah. So now next step. Now a polygon will be made trapping station in it. So yes, now we have this polygon, this one, which is in which station K is trapped. Okay, so you will say that now the K is out of the border, but no problem. This whole area, whatever area it is there, it is given to the area, to the station K. Okay, so let's mark this point. Yeah. Okay, so this area, this polygon belongs to K. Okay, so according to this, we have now trapped K in a polygon. Okay, so now from trapped station, connect the adjacent station by straight lines and go to the same procedure until all the stations are separated by polygon. So here is, okay, there's a problem here. Let me cancel it. Yeah. Okay, so just what you have to do is that connect the adjacent stations with straight lines and do the same procedure until all the stations are separated by polygons. Okay, so what does this mean is that now we have plotted at point K and G, right? Means we have drawn a straight line from point K to G. Now in the same way we have to see the adjacent lines of G, so that is GJ and GE also. Okay, so let's plot it. This is G, this is E. Okay, and the other point is GJ. This is J and this is G. Okay, so as you can see, I have plotted the lines. Now I have to bisect them. So let's see how much long it is. So they are nearly 6.4 centimeter. Okay, so 6.4, so it will bisect at 3.2, so it is here. Okay, so let's mark it. 3.2 is here. Okay, so mark it. Now at the same time, I'll mark this point also. Here the bisection is at 3.6. Okay, here it is at 3.6. So it will be 1.8 will be the bisecting point. So where is 1.8? It is here. Okay, we have to bisect it at this point. Oops. Okay, so we have to bisect them at 2 points. So using protractor. Okay, so it will be okay. So as I told you, you have to mark this line under this diagram only, under this boundary only. Okay, you don't have to go out of the boundary. So now you will be saying that yes bro, you have drawn only a half line, why not full? So I will tell you, see, this line is also here. So when I will bisect here, means for example you think I have drawn this, I have extended this line just till here, till this point I have extended. Okay, no problem, you can extend it. But I will tell you why I haven't extended. See, now I am bisecting this line. This line is here, the line G and E. Okay, I am bisecting and okay, so this line is cutting here. So now you can see that the intersection line, the intersection point between the perpendicular of J and G and G and E, means this line and this line is interconnecting at this point. So at the point which it interconnects, we have to stop both the lines there itself. So it interconnected here, so we'll stop both the lines here. That's why I haven't drawn this line. Okay, so I hope you understood this thing. So we have to stop this line here itself. Yeah, it is stopped. Now we will rub these lines, the lines which we have made to find out the perpendicular. Yeah, in this work you have to rub a lot of time. Rubbing and erasing, it will go on. So let me darken this once again. Yeah, okay. Just darken. Let this line properly. Yeah. So once. Yeah, this line is made. Now this line also, once I will make it. This is also made. Okay, so now the second step, you have to again make the adjacent line from J and from J to E. Let's make it. So till what you have to make it? Till each and every station is trapped under a box. So now you can see here the station G is trapped into a polygon, right? K is trapped here, G is trapped here. Now the next one is J and E. So we'll connect these lines. So J is here and E is here. Okay, so let's connect it. Okay. So let's count how much centimeter long is this line. So it is showing it is 6.4 centimeter, which equals to 3.2 centimeter. It will bisect. 3 is here, 3.1, 3.2 is here. Okay, it will bisect at this point. So let's count it. Yeah, okay. So I'll keep a protractor here. Yeah, 3.2 is here. Okay. Okay, I have find out the line. Yeah, so it will bisect here. So as you can see, the three lines are interconnected here. Yeah, so the three lines got interconnected here. So I will rub this line, extra line. You have to rub a lot of time. You have to rub, you have to make again and again lines here till the time you trapped all the stations. So here station K, station G and station J. J is also trapped in this box, this polygon, sorry. Now next we will connect E and F and E and C. So let's connect it. And let's see how much big we get the polygon of E, station E. So where is this? It is here, connected, and the second one is C. Connected. So let's count it, how long it is. If you have figured out, you can ask in the comment box. I will reply you. This is 1 centimeter, 5. Okay, so it is total 5 centimeter only. Okay. So the center point will be 2.5. So it is here. 2.5 is here. So let's mark this point and let's see the perpendicular point of it. Okay, so it will be bisecting here. Make a line. This time also I have made it till here only because I can see the bisecting point will be crossing down here. The bisecting point of this line C and E. So let's calculate that line also. So this is nearly 1 centimeter, 2, 3, it is 3.5 I think, yeah. So center will be 1.5, 1.6, 1.7, so it is nearly 1.8. Between 1.8 and 1.7 actually. Okay, so from here, now let's find out the perpendicular. Yeah. Okay, so we have got the polygon for station E also. So now we will rub the extra lines. So let's rub it. Okay, so let's connect these lines once again. So we have got station E also here separate out. Yeah, so K, G, J and E is separated. It's time to connect C and F. So why are we waiting for it? Let's connect it. C is here, F is here. So connected. Let's see the center point. Okay, it is 4.2 centimeters, so it will be divided into 2.1. This is the 2.1. Okay, my lead pencil lead is over. Let's add another lead into lead pencil. Yeah, ready. So we have got our center point here. Now we'll find the perpendicular. Okay, so it's nearly here. So let's connect it. I haven't extended it much higher because I know it will be cut it down here by some other lines. So let's rub this line, extra line, whose work is over. Okay. So now let's connect the line C and I. Okay. This line is connected. So let's calculate its value. It is 6.5. But 6.6 also we can say it is, because it is nearly between 6.5 and 6.6. So I will take it as 6.6. So it will be 3.3 the bisecting point. It's bisected from here. Okay, it is this point is bisecting. First, let's rub this line, then I will draw. Okay. I have bisected this line. Now the next part is okay, I have to rub this side also. So you will be now confusing, till now these are not trapped, we have drawn the adjacent lines. So no problem, you just have to draw the adjacent lines to everyone and you have to perpendicular. Okay, till they are trapped. So for example, now we have drawn a line between C and I, still they are not trapped. But when we will draw a line between C and A, the I will be trapped. Okay, so we will draw a line between C and A and we will trap it. Okay, so it is here. Total it is 6.4 centimeter. So it will divide it at 3.2 centimeter. So let's divide it at 3.2 centimeter. This point. So we'll not extend our line more than this, because we can see this line is coming from already the extending line it is. So we'll drop all the lines from here. We'll extend this line from here onwards. Yeah. Okay, so I have extended the line. So you might be thinking now, here this line should bisect, should join here, because this is also the perpendicular line, this is also a perpendicular line, so we both can join here. But no, because see here we have to draw a line between F and D, and after perpendicular it, this line will be cutted down. Okay. So now, as we were doing, which one? We were trying to trap the point I, right? So here we have drawn a line between C and A, and we got the perpendicular line, that is this one. Still we haven't trapped the point I. So now we will draw a line between I and A, and then the station A will be trapped. So let's draw a line between I and A. Okay, we have drawn the line. Let's calculate how much centimeter it is. This is nearly 4.6. No, it's 4.7. No, it's 4.6 centimeter. Okay, it's 4.6. So the dividing point will be 2.3 centimeter, which is here, and it's center. It will cut it down at the point where it is. Let's see it. Here's some mistake. Yeah. Okay. So where was I? Yeah, where is your center point? Let's calculate. It is 4.6 and the center is 2.3. Okay, so it will be nearly perpendicular. Actually, this line will connect here. So let's connect it. Yeah, and here we get our. Okay, there's a mistake here. Let's find out. First, let me draw this line properly. Yeah, it's made here. Okay, so I have drawn these lines, and now we will draw our line. Okay, so our line. So perpendicular angle. This point is, yeah, it is here. Connecting this. So it is connected here. Now let's rub the extra line. Now again the border. Okay, so this we have done. So here session I is different. Okay, there is one small problem. Let me tell you, which we haven't seen it actually. So the problem is this: the line, this line, should get connected here. By mistake, I have connected it here. So let me. That's what I was thinking. Actually, see, this line comes from here and this line comes from here, right? So if they are interconnected here, so according to our rule, we cannot extend this line, and we have extended this line. So which means this line is connecting here. So by mistake, I have done it. Let me connect it. Correct it. Yeah. Now it's right. So yeah. So we have got I is different. C is yet not completed because here the gap is there. You can see. So now we'll connect to which point? Okay, we have got I. Now we can connect A and H and A and B to trap A. But I am thinking to first connect F and D and trap F. So first we'll connect that. F and D will connect. F and D is here. So F and D is connected here. Now we'll calculate it. F is this 4.3 centimeter. So 2.15. 2.15 is here. So you have to calculate here very properly and precisely, because if the lines don't get connect properly, then you won't get proper correct area. Here some error is acceptable, no problem. You can bring the approximate answer. So try to find out the correct answer. Okay. So as you can see here, this was a perpendicular line, this was a perpendicular line, so it is cutting here. So I will rub this point, and I will rub this extra line. Okay, so this is here, and we can see the F station F is trapped. Let's rub all other things. This is our station D. So we have trapped F also now. It's done for D and L and D and B. So we'll connect to D and L. D and L will be here joining, and B and D will be joining here. So let's find out how much centimeter they are. It is 3.5 centimeter. So which means 3.5, 1.5, 1.6, 1.7. So it will be nearly 1.7 to 1.8. So it is here. Yeah. So this point is here. You have to bisect the line from here. So where is the 90 degree? First find it out. So exactly going it through here. So as you can see, when I will draw this whole line, one line is connecting at this boundary, one line is connecting at this boundary. So the small gap is for L, the small point. Let me rub the other lines and let's draw it once again. Yeah. So we got L also here. Now it's time for B and D. How long they are, let's see it. So B and D are 4.2 centimeters. So dividing point will be 2.1. So 2.1 is here. Okay, so it is connecting exactly at this point. So let's connect it. Yeah. So this is connected. Okay, so point B and D is connected. So now we will drop the extra line. Oh, by mistake I have rubbed the perpendicular line itself. But I know where it is. Let's do it once again. This line is from here to here. It's 2.1, center comes here. Okay, I know the center. Still I have to make a line. 2.1 here. So I will extend this line. I see. Now I can connect this line by here and we can cut this line. But let's stop for a while and first we will rub this extra line and we will find out, because sometimes what happens, the other line can also bisect before this line bisect. Means for example, if I draw a line between A and B, because I think here, so I was saying that when we will draw a line between A and B and we will bisect it, so the line will connect this line, the perpendicular line will connect this line before this line connects this line. So let me show you. I think you are not getting it. Still I will show you. So see here. So we will draw this line first. So I have drawn the line from A to B. So let's see what is how much long this line is. So this line is nearly, it is 4.5, it's 4.5 centimeter. There is a problem. So it means that the line D and F, this is the bisector of D and F, and this is the bisector of C and F. So we have drawn the CF bisector and DF bisector wrong, so we will plot it again. So yeah, we have to do extra hard work now because we have done something wrong. So we'll do one thing, we will rub these lines. Yes. So we'll again connect these lines C, D and C, sorry, D and F, and now F and C, and we have connected this line also. Okay, so now we have to bisect these points, all the lines. So it is 4.4, so it will be 2.2, it will be there, so it is nearly here. So previously I have done 2.1, so now it is on 2.2, so that was a mistake. And yeah, as you can see, only by one mistake there was a whole problem, right? So here every single millimeter counts, so be aware of it. And let's see, for this it is 4 point, it is also 4.4, so it is also 2.2. So see, here I have done 2.4, I have written before, I have marked it out 2.4, now it is 2.2 only. So that's why there are small mistakes, just by mistake it went little bit forward. So I think now it will be correct. Yeah. So the perpendicular point of this is this, where is right passing from the center, this. Okay, so let's draw it. Okay, so it is coming nearly here. Yeah. So now I made our point here, and let's make it more properly. We got this point, and the next one is we want to take a 90 degree from here. So 90 degree from here will be, yeah, this is also coming exactly from here. So see, just by a difference of 1 millimeter there was a problem, right? Now it is right. So we'll rub these lines. So you can see how small mistakes can give a large difference, right? You will be confused, oh my god, what I have done. You were right, but just a small millimeter mistake had made this big situation, right? So now again we have to make a 90 degree from this line also. So this will be nearly, where is the line? It is here. Yeah. So we have to make a line from here to here, and that is okay. So now let's rub the other lines. We have rubbed all the lines. This point C, point station D it is, and this is the line. Yeah. Okay, so as you can see, station D is separate out finally, right? And this line is intersected here, so we will rub this extra line. This extra line is rubbed. Now it's point, it's time to interconnect, it's time to connect these two lines, line B and line C. So its intersecting point is 7.5. It's totally 7.5. So 3.5, 3.7. So it is nearly here. This is the exact center. Is here 90 degree. So as you can see here, this is a very small line. Only a small line it is there because both the side perpendiculars are there. So only a small line is that. So can you see how many lines are there? 1, 2, 3, 4, 5, 6. So this polygon is made up of 6. This station number C, station C, have 6 polygon, and finally we have trapped station C. So it took a lot of time, right? Yeah, it happens normally. So now the last is we have to connect AH and BH. So let's connect it and find it out what next. And first extend this line. This is the perpendicular line. When did we got this? When we have connected A and B. So I'm just extending this line. I'm doing nothing else. Yeah. So let's connect A and H and B and H. So I have connected. Let's find out the center. This is 1 centimeter and this is 4.6. No, it's 4.7. I think 4.8 centimeter. So 4.8 means 2.4 centimeter. So it will be nearly here. Yeah. Okay. Perpendicular to it. So it will be nearly here. You have to be very careful while doing this. Okay, so we will stop this line here itself because they are cut it down here. And the next step is we have to find the centimeter between these two. So it is exactly 4 centimeter. So it means it will cut it at 2 centimeter. So it is here and 2 centimeter will be nearly here. Yeah, so we have find out this line and we have to extend this line also. Okay, so here we go. Yeah, finally all the polygons are trapped. Yeah, so we'll make this border again. Yeah, so here we go. So as you can see now, let's check it out once again. So it took nearly a lot of time, I think nearly 1 hour, I think. So where was I? See, this is a station. This is the area of station K, area of station G, area of station J, area of station E, area of station F. This is the area of C, area of D, area of B, area of A, area of I, and area of H. So we have got here 12 polygons in this diagram. Okay. So this is how we have to plot the diagrams. Yeah, I was means if I told you just a simple step and do it according to that, but I haven't told like this because many times, as you have seen in, even though when we were doing, we have came into mistakes just because a difference of only 1 millimeter. So that's why I have shown you this whole video, and please do with me. So when you do with me, so it's better to understand for every one of us. So this is the part 1. In part 2 I will explain you how to calculate the area. Means our graph work is over. Now we have to do this table. Means the main, what was our question? Find annual rainfall by Thiessen polygon method. So we have done half part. Now another half part I will explain you in the video 2. So let's check it out, that one. So see you in the next video. Hope all of you like the video, and more than liking, I hope all of you understand this video. If you still have any doubt, query, just ask it in the comment section. Okay. So see you in the next video where we will find out the area of this polygon and we will find out the average rainfall. Okay. So see you in the next video. Till then, bye bye.